All right, so some introduction to some constructions as well as definitions today. So you should start in your classroom, MCPS classroom here. Couple different ways to get there. We have our weekly learning. Will always show us what we're working on, as well as you can go in through modules. I would suggest weekly learning. And because it has everything in here, I will start to put these recordings as I do them. If I do them without you all, then I can put them up forever and you can look at them when you can, or review them as you need it. All right. You will need to, if I reset the student view, you will have to go through all of these. Excuse me, but I get to show you again. Weekly learning, and we're going to start intro to constructions. All right, so you have to start with your introduction, and you will have to click through everything before you can get to today's assessment. It's just a vocab assessment real quick for about 4 words, so give that a try. We are focusing on our definitions as well as starting those constructions, and that's what this is saying here. So as we click through, there is a Desmos activity. All right, so open this up. This is from my side. I'm going to create a new one, and here we go. So this is what you would sign into. Feel free, you can actually sign in using this this Desmos, and that way I can see if you did this after by following the video, which is fine. All right, but it's just going to be me, so I will walk you through it. Our first thing here is to combine or get together all the things that mean the same thing. It's a card sort, right? So we have points, we have lines, we have rays, and we have line segments. All right, so the way I think about it, or I'm going to grab these things, here we have DE here. I can see that those are dots, right, on the end. That means it stops, it terminates, it ends. That is going to be a line segment, right? I think about a segment, I often think about like a news segment, right? If you're watching the news, a segment is just a part of the show, not the whole show. Well, a line segment is a part of a line, not a whole line. So it does have a finite amount of well, that gets confusing, but it does stop. So think of it as finite and stopping. Here, a line versus is going to have no endpoints, right? It's going to continue on forever in both directions. The way you need to start thinking about geometry is in this kind of, it is tangible, it is something you can draw, it is all those things, but at the same time, it's a theory, right? This line, as I go, is going to go to space that way forever, to the well-known universe or unknown universe, because we don't know all of it. And this one's going to go down through the earth and cut through, like theoretically. It doesn't actually do it, but it does, right? We have these in space. All right. Also here, let's see, this one, right? I'm trying to do all the pictures. This one is a ray, okay? It has one point that starts and then it goes forever in one direction. So if I'm like this, right, it's going to go forever up to space, never going to stop. I think of it like a ray of sunshine, right? Ray of sunshine starts at the sun and goes forever. Well, the sun's case in all directions, but if we think about the one that's coming through the window and hitting us right now, it is starting at the sun, and if I wasn't here, it would keep going till it hits something else. Now, if it doesn't hit anything else, like it doesn't hit another planet, those light waves could go forever, right? And that's why we look out in the stars and we see those stars. Those stars may be gone millions and hundreds of millions of years ago, but they are, the light is coming to us, right? So it's always going in one direction. And then here we have our point, right? It is infinitesimally small. That means we cannot measure it. It doesn't have anything that we can measure, but we can understand it as a space, right? As a little whoop. If I had the sharpest pen in the whole world and made a dot, it's even smaller than that, right? It's infinitesimally small, but it represents a place in space. All right, so these are all of our definitions, and I want to just move this rest of the stuff. And it does take a little finagling to get through this, but that's okay. All right, so those are what they look like. So if I want to tie in another way, it would be to name it, right? So here we have our first one, and I notice that, let me grab my little annotation tool, that one side has an arrow, the other side does not, right? So that means it's going on forever in one direction, but not the other. Another thing to keep in mind is that, and I'm going to move this up here, this is a ray. This will, you have to name it in the order, right? It starts at H and goes to G. This one would say that it starts at G and goes to H, and that's not right. All right, so here we have the line one. This is line AB. This is line AC. This is line CA. This is line BA. This is line, it doesn't matter, right? Because they go forever in every direction, it doesn't matter which way you name it. Line segment, it does, right? You will just have, so I should say the difference between this one and this one is this one has arrows on both sides versus this one does not, right? And then there's point A. All right, oops, there's point A. Okay, let's look at some of these definitions. All right, defined by 2 points, contains infinite points, infinitely long, and goes in 2 directions. Well, that is my line. Something that is a part of a line, has 1 endpoint, continues infinitely in one direction, sounds like a ray of sunshine. It is a ray. A location in space, has no shape or size. I read that backwards. Still, both are a point. And then finally, a part of a line has 2 endpoints and contains infinite points, is your line segment. All right, has a finite length, yes, finite stops, right? Good. Next, I contain many points. I have absolute starting and ending place. I have a set length. What am I? That is a line segment. Our next one, I'm an exact location in space. I can stand alone. They call me a capital letter. Who am I? I am a point. You don't have to write I am a point, but I just did. That's okay. All right. Next one. I love to keep going like running a race. I often go back and forth just to take up space. I can be labeled with a lowercase cursive letter or for short, AKA by 2 points. Who am I? That is a line. And finally, I can be as fast as lightning in one direction. I have an official start. I'm part of a line. What am I? A ray. Again, think like a ray of sunshine. All right, so that's that activity. I would like for you to try it, give it a shot, see how it is, order them for yourself, and put those definitions in. All right, so the next activity is to watch these videos. Now, I'll watch them here, right? I can give you that time. I'm going to share with sound, and we're going to watch the video, and then I'm going to show you how to do it on your geometry tool. Now, if you don't have that, you can go to our home screen. We have the Geometry Desmos tool, or Desmos Geometry. Google it, and it's right there. Okay? So we'll play around with it after the video. But here's a copy of line segment.
Welcome to this video on using Desmos to do constructions. In this video, we'll be copying a segment. I have a segment already drawn, and I wish to copy that segment. The first thing that I need to do is to create a line. What I'll be using this line to do is actually cut out the segment that I copy. I'm going to use my More Tools feature and my compass. I'm using my compass to measure the segment that I wish to copy. In this case, by selecting the segment, you can see I automatically created a circle whose radius is that segment. I can then drag that circle onto the line where I wish to copy the segment. Because I centered it at a point that I already have on the line, I can now construct the segment. from that point to the edge of the circle. I can even select that segment and change the color so that it's clear that I now have my new copy of a segment. I hope that you enjoyed this video on using Desmos to do some basic constructions.
All right, so that was made by the district, but let's do that as well. So the way you're going to do it is draw any segment, right? I'm going to draw mine this way because I feel like it. That's what I want to copy. So actually, what I'm going to do is I'm going to lock these points so that I can't move them. You don't have to do this. I'm just doing it so you know that I am not changing it and measuring it. All right, so first thing we do is we draw a random line. Doesn't have to be parallel. It can be this way. That's all I'm going to do. All right, that's where I'm going to construct my new line segment. So the first thing you do is go to More Tools, not Circle, right? My first goal is to go, like, I want to make a circle. Go to the Circle tool. No. I want to go to my compass tool because that's going to measure this for me. So as soon as I'm on my compass tool, I click it, this now automatically made a circle that matches that, right? That matches the radius, right? So this line here, this circle, anything I do with it is going to stay that size and it's going to give me this same radius. So I'm going to create my circle here, and I'll just use this point that already exists. If I want to, I could get another one, but it already exists, might as well. I'm going to place that one there. Now I can copy my segment because any radius here, from here to here, or any other one here to here, all of these lines are going to be exactly the same length. And I can show you that and prove it to you because this length is 3.36 centimeters, inches, doesn't matter. It's 3.36. This line is, click that line, 3.36. This line, 3.36. This line, 3.36, right? So all of them are 3.36 units. We'll call it units. All right, that's how you create one. Watch this again. Watch the other one as well to see if that's helpful. Next one.
Welcome to this video on using the Desmos geometry tools to complete a simple construction, in this case, copy an angle. The first thing that I'm going to do is actually use my circle tool. By using my circle tool on my original angle, what I'm actually doing is defining an isosceles triangle. I now know that these two sides of the angle are actually the same length. They're both the radius of this large circle. I was then able to complete a segment. That segment defines the base of my isosceles triangle. By using the copy and segment feature, we're going to be able to construct a congruent angle. I'm actually going to start with an arbitrary line. Somewhere on this line, I'll be constructing the angle. I'm going to use my compass tool, and I'm going to choose a segment to be the radius of this circle. In this case, I'll use this top leg. I'm going to put it at an arbitrary place along this line. And I now have part of my angle. It'll be one of the radii that are visible of this circle. I'm going to use that compass again. I'm going to select a segment. I now have a circle whose radius is that segment, or the base of my isosceles triangle. I'll place it where it should be, at that point of intersection, and I can now build a segment from the point of intersection of the two circles to the center of my larger circle. What I can now do is use my angle tool to verify that my angles are congruent. 21 degrees. 21 degrees. In this video, we copied segments using the compass tool to construct congruent angles.
All right, awesome. So while we're in our geometry tool, so this one's still here, that's fine. I do want to remind you in the last video does say this, so I'm going to skip over and just tell you now. If you right click here, if you're using a laptop, if you're using a Chromebook, the way to right click is you tap it with 2 fingers, just like that, and it will come up something like a copy image or a save image as. If you copy image, you can put it into a Cami document, and then you can turn it into me, etc. Save as, same thing. You could save it, and then you can use it for a later date. They're both available for it. But right now, I'm just going to delete. Okay, so we need to make an angle and then copy it. So here is my angle. It's helpful if one is longer than the other, but I'm actually going to move this a little smaller because I don't want my circles to be giant. And I can make this whatever I want it to be. That's fine. First step is to create a line anywhere you want. Then we're going to make a circle, right? We're going to make this circle this size, right? Sometimes I forget the step, but that's okay. That's this size. Now I can copy this circle, or actually pause. Why are we doing that? Well, if I have this point here and this point here, it makes that isosceles triangle that he was talking about in the video, and that becomes really helpful. But what it is saying is that from here to here is a radii, just as here to here is a radii. All right, so what I'm going to use next is the compass tool. I'm going to hit on the compass, and I am going to make this circle anywhere on this line, right? As soon as I click on it, as soon as I click on that line, this tool knows that that's the radii of the circle that I want to make. Boom, it's right there. Take some practice. The first time I was playing with it, I was a little lost. Then I'm going to use the compass again, but now I'm going to choose this as my radius. Right, so that's my radius. Why does that help? Well, if I put this circle on the line where it crosses the circle and the line intersect, right, that is going to give me the right radii here, right? So this one is going to match from here to here. Now, that's not really what I'm testing, but it's the same length, so it is helpful. What I'm looking for is actually the one from here, and I'm going to do it as a ray because all angles are actually rays, and go there. Oops, I'm going to go right on the point. It does kind of snap it to the right point when you're playing with it. To check, boom, boom, boom. This is a 40-degree angle, and here we have boom, 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 another 40-degree angle. Go play, go play. All right, so I have 2 40-degree angles, so I've copied my angle. Now, if all of this looks way too messy for you, you can hide stuff, right? If I click here with my select tool, I can hide it, right? I can hide all of this stuff, so now it doesn't look so messy. There's no problem with it being that messy for me, but if you don't like it, then there you go. So those 2 angles are going to be the same. All right, finally, we will watch. We're going to go this way, and then perpendicular bisector.
Welcome to this video tutorial on using the Desmos geometry tools to do a simple construction. For this video, we'll be doing a perpendicular bisector. I have a segment that I wish to bisect. One of the first things I'll do is draw 2 circles.
Just as a quick note, perpendicular, remember, is 90 degrees, right? When 2 things hit at 90 degrees, that's perpendicular. Any sort of sheet of paper that I do not have handy. Here's a piece. Sorry, I have scratch paper everywhere. This is a right angle. This is 90 degrees. So we're trying to make this line and cut it at 90 degrees. It should be perpendicular, as well as it's a bisector. And remember, bi means cut into 2, because bi means 2. A bicycle has 2 wheels. You know, that's what bi means. Bicentennial is 200 years. What are some other examples? You can fill that in. But we want to cut this into 2 equal parts with a line that's perpendicular, with a line that meets at 90 degrees.
Circles. The 2 circles I draw will both have a radius that is this segment. Because the circles have the same radius, I can draw several radii. From this point to this circle, but actually at the point of intersection. Because all the radii I've drawn are of equal distance, I know that these 2 points at the top and bottom are equally distant from either of these 2 points. I'm going to use my line tool to draw the line that connects these 2 top and bottom points. At this point, I've bisected the line. I want to verify that the angles are 90 degrees. Sure enough, I have 90-degree angles. If I wanted to verify that it is in fact bisected, I could use my compass tool. I'm going to start with the segment that is just half of it. If I use my compass, I can see that both sides are the same. In this video, we use the circles and constructions within Desmos to bisect a segment.
All right, great. So what that's going to look like, again, I could copy this, and I'm not going to show you the last video because we'll talk about it a lot, but we can save image, copy image as we want. All right, but I am going to erase it for right now. Okay, so we have to create a perpendicular bisector. So we have a segment here, right? It could be anyway, but I'm just going to do it there. Not perfectly straight, but that's fine. I'm using the circle tool this time. Last time I was using the compass tool, but I am going to use the circle tool. And the way that you use that is you pick the center. So that's my center. And I want this circle to have a radius of this line. So I'm going to use the line for reference. Do the same thing in the other direction. Now it's the center of the circle. And now the radius is the same. I'm running out of space on the top. Not a big deal. He did some other things that show the properties of it, but if you're trying to do a perpendicular bisector, we can actually do it from right here, right? What we have is we have the 2 points where these 2 circles intersect. If I connect those with a line, I have created a perpendicular bisector because if I do my angles here, boom, 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 that's 90 degrees, boom, boom. I'm sorry, I don't know why I do sound effects. 90 degrees, right? So those are 90 degrees. The other thing he checked, right, is that they were the bisector. Well, if I draw a new segment, and sometimes this does it better than others, and if I then label that segment, it is 1.79. I'm going to do the same thing here to here. If I label it, it is going to be, again, 1.79. Now, the other stuff he was talking about, well, it makes equilateral triangles, right? What we can do is we have this segment from here to here, or here to here. That's going to create an isosceles triangle because these circles have the same radii, and those are just 2 radiuses. Radii, that's the plural of radius. All right, so that is 3.57. This side would also be 3.57. Gorgeous. Now let me see if I can move this. If it'll let me do it. Oops, no. Oh, I can move that. That's exciting. You got to learn new things all the time. So for example, if I go from here, I'm sorry, I should be on segment. If I go from here to here and here to here, right? Those are actually going to be the same. And I can move, oops, is it going to let me do it? Nope, now it's doing crazy stuff. Ugh. All these people coming into class early. If I label these 2.47, 2.47, but if I start moving them, you'll notice that they're the same, right? So what it's saying is any line on this perpendicular bisector, is going to be equidistant or the same distance to those 2 points. It's always going to make an isosceles triangle. All right. So that's that. That's the bulk of the learning of what you were supposed to do today. I would like for you to practice those, right, using the geometry tool. This last one is just to save your drawings, but we'll keep talking about that. And then we have this, what I would like you to do is try these out, just play around with it, and that'll be good. Next, we can see that they have our summary of those 4 things that were very, very important for definitions to start. And then this is to copy a line segment. Again, I do want you to practice all of those. And then a quiz at the end. All right, so that was what we covered in class on, well, Monday and Tuesday, the 14th and 15th. If you have any questions, please feel free to email me. See you soon. And watch us as many times as you want to.